Hello friends, I'm Engineer Nasir. In this video, we'll do a sample calculation to calculate the pressure drop inside a rectangular duct elbow. To calculate the pressure drop inside a rectangular duct elbow, we use this formula Tp equal to C into Vp. Tp total pressure drop inside the elbow, C duct fitting loss coefficient, which we will find from the ASHRAE table, and V velocity pressure we can calculate by this formula. We use this formula if velocity in fpm, and if the velocity in meter per second, then we use this formula to calculate the velocity pressure. We use two types of elbow, one with vanes and the other without vanes. For rectangular duct elbow without vanes, we will use this table to select the coefficient, and for vane with vanes, we will use this table. Now we'll use this table to select the coefficient for a vane 90-degree elbow size 850 by 400 mm. To select the coefficient from this table, we need to calculate two values, h by w and r by w. H is elbow height, w is elbow width, and small r center radius. For this elbow with 850, h equal to 400 and center radius 525. Then h by w is 0.47 and r by w 0.62. H by w 0.47, so we'll see the nearest value. We found this 0.5, so we will select this column. Then r by w 0.62, this is 0.60 and 0.65, so it is the nearest. Then we will select this row. So we have selected the coefficient for this value equal to 0.27. Now from shop drawing, we will find the velocity inside this elbow. Elbow size is 850 by 400 and airflow in this elbow is 2000 liter per second. Now to calculate the velocity, you can use McQuay calculator or friction loss chart from ASHRAE. These values are in metric system, so first we will change the unit from here. Flow is 2000 liter per second, psi is 850 by 400. So the velocity in this duct is 6.489 meter per second. This is friction loss chart. Here airflow is liter per second, okay. But the duct size is in round duct diameter. So first we will select the equivalent round diameter for our rectangular duct size. Our duct size is 850 by 400. So let us see 850 here. Here 800, 900. So we will select both values 800 and 900. Then other value is 400. We will select this column. Now we will select both these values for 800 equivalent and 900 equivalent, and by interpolation we will find the equivalent diameter for 850. For 800 rectangular duct size, we have equivalent round diameter value 609, and for 900 we have equivalent round duct diameter 643. So for 850 we will have equivalent round duct diameter value equal to 626. अब मैं McQuay कैलकुलेटर से भी कंफर्म कर लेते हैं. फ्लो है 2000 लीटर पर सेकेंड, डक्ट साइज है 850 बाई 400, तो इक्विवेलेंट डायमीटर की वैल्यू आ जाती है 626. एयर फ्लो इज 2000 liter per second and equivalent round duct diameter value is 626. Here we draw a line for 2000 liter per second, straight vertical line. Then these lines are for round duct diameter. So 400, 500, 630. So we draw a line for 626 millimeter. And at the point of intersection of these two lines, we draw a line parallel to velocity line. You can see this velocity line here. So this velocity value 5 meter per second, 6 meter per second, and 7 meter per second. So the velocity in this duct is 6.5 meter per second. Velocity in this elbow is 6.5 meter per second. Then velocity pressure will be equal to 25.43. And we have selected fitting loss coefficient for this elbow equal to 0.27. Then the total pressure drop inside this elbow is equal to 6.86 Pascal.